Okay, so this paper that I gave you shows you the strategies how to solve equations. So there's two branches on here. You either are going to see equations that have just one variable type in it or two variable types. So do you see just the difference between these? So this has an x squared, and that's the only type of variable you see. This has an x squared and an x. So that is two different things. Okay? Some think, well, it's still the letter x. Well, I always say, think about having square footage in your house and linear footage. They are different things. You can't put them together. Okay, so that's that. We're going to learn that when you have one variable, you can isolate. Okay? Isolate is your algebra where you move something over, divide it out, right? You're just trying to get something alone. Okay? So that's what isolation is. And when you have two variables, you're going to learn that an equation will have to equal 0. And then we go through this, factoring. You've learned all this in grade 10. We will go through it in more depth now. So we've learned factoring. We've seen these styles. Gcf, does that sound familiar to you, those words? Yeah. Simple trinomial, we've already touched base on that one. Complex trinomial, we didn't recap it last unit, but you did it in grade 10. And the difference of squares. Okay, then you're going to learn something new. So you didn't do this in grade 10. You're going to learn if it doesn't factor, sometimes they just don't factor, we're going to learn a formula that will get us the answer. Okay? And sometimes things don't factor because the answer ends up being 1.269432, right? Like something that's not a nice number. That's why it wouldn't factor. Okay? This is also going to connect to when we graphed quadratics, because if this is a quadratic and it equals 0, when I'm solving, these are actually the what to the graph? X-intercepts. Okay? Then grade 12, you get to do some of this stuff with cubic functions instead of quadratic functions. You're just going to add on layers and layers. Okay, so let's get started. So the first part of the algebra branch is, what if I go this way and only have one variable type? So isolation. Okay. So what does isolation look like? Okay, so I'm going to do what to get this alone? Add 49. Okay, so isolation is move stuff or get rid of stuff. You're trying to get something alone. So I still need x alone. How do I get rid of a squared? Square root. And that cancels it off. Okay, the answer is not 7. You get half of a point. That's a half of a point of an answer. I'm missing something. Does anybody know what? Yeah, positive or -7.
Oh, so you have to write either.
Yeah, there's two answers.
Always?
On this, yeah, on that type. Because think about it. What squared makes 49? Does 7 squared make 49?
And -7.
And does -7 squared also make 49? Yeah, there's two answers. Also, last unit, I learned that this is a parabola that's down at 49. Where's it hitting? -7 and 7.
No way.
So if you answer just 7, it's throwing off all the concepts that we've learned. No, but I just want you to understand this is why there's two answers. makes you realize why there's two answers. Okay. Next one. I'm going to subtract 81, if that's all right with you. Okay, so I subtracted 81, and now I would like the m alone, so I'm going to square root.
So you need a positive and a negative.
What's different about this idea?
It's a negative 8. It can't be, because then it's just squared and you, like,
Yeah?
it's positive.
Yep. Right.
You need
If
one
you
of each.
square something, it turns positive, right? It doesn't matter. So then what's going to happen here?
You need one of each.
You need one of each, but then that wouldn't be squaring something.
Well, then you'll do positive and negative. It's an error.
It's an error. So we're going to write this in math. There is no solution for m. There's no way we can make something work. Because you're thinking, well, 9 squared. Well, no, that's positive 81. Negative 9 squared. No, that's still positive. What's my visual representation in my mind? M squared plus 81. So it's a parabola way up at 81. Where's that crossing the x-axis? Never. There's no way that's going to ever cross. And that's mathematically why. Okay, next one. I'm going to add 22. Okay, that's moved. Now I'm going to square root.
Yep.
Okay, you probably jumped to your calculator, right? Because that doesn't have one of those perfect numbers in my head. It's a decimal, okay? We're going to learn in math a lot of the times we're not going to do decimal numbers. We're just going to leave it like that because it's not something that's exact. But now I also need to put a plus minus in front. Just like this one. Okay? It's just different because it wasn't a nice, pretty, exact thing. So we leave those. Okay. Here's a test to your algebra. We're going to be moving a lot of stuff, but the order is very important. Okay, so when I think of bed mass, I'm actually doing that all backwards. So Sam Deb. Okay, what should I move first? The 2. So here I'm going to add 2 because this is a unit. It's all tied together. It's glued together. So I can't maneuver stuff with it yet until I get rid of that.
You can multiply by 3.
So now I'm going to multiply by 3.
And then you can add 5.
Okay, so the order is important. Add 2, that's first, times by 3. Add by 5. Add 5. Okay, you're still following. Divide by 2. Now one more thing. Square root. And how do you want to write this as an answer? B could be positive or negative 4. Okay, algebra order. Be careful. Go slow. Think about. If you're stuck with your algebra steps, here's my hint. If I knew b, this is how I would go about it. I would do b squared, then I would times it by 2, then I would subtract 5. Then I would take that and divide by 3, and then I would take that and minus 2. So now I go backwards of all those things. Okay, next. Okay, when you look at this, I really want you to think hard. Are we on the one variable side or the two variable side of strategies? We still have just one variable. There's x squareds and x squareds. That's only one type. Okay, so this is from grade 9. You would have done equation solving like this. When you have variables on both sides, you have to put them together.
Yeah, so you just like do the opposites.
Yeah. I always suggest getting rid of the one that's smaller. So I'm going to minus 4x squared. Okay, that's my suggestion because that way you're not creating negative numbers. It's okay to do it the other way, but you're going to involve negative numbers. So I'm going to get rid of that. Okay, I can put that together. Okay, so that's my first step. I always tackle the variables to make sure they're together first. Now I'm going to move the numbers. Divide by 2. And then I'm going to square root both sides, so I get x equals square root of 6. I'm going to leave because it's a decimal and I don't want to write a decimal. Okay, so that is isolation. So I made sure I did an example where sometimes you're going to run into no solution. Sometimes you're going to run into numbers that don't square root. Sometimes you're going to run into numbers that do nicely square root. Okay, let's do simple trinomials. Because I think some of this will be a little bit fast review for you. Okay. So a simple trinomial, again, always starts with a 1x squared. That's how I know it's a simple. We always have our 3 parts. Then we always say that the 2 numbers we factor with will do what to the end? Multiply and add to the middle. So when I break down FOIL, that's how it's breaking down. This is always the F's. The last part is the 15 part. And these add together. So that's always the OI together. Okay, so first, what times what makes x squared? X times x. L is where I look next and I say what times what makes 15, so I have 115, 5, 3. But the combo has to add to a 2, 5 and 3, and because this is a negative 15, there will be 1 negative, 1 positive. Okay, so those were the things I was thinking about. Then, do we remember how to write the answer? What is going to cause that bracket to produce a 0? Negative 5, positive 3. Okay? Do you understand if somebody wrote me this, it would be an error?
Yeah, because it's not like a thing.
That's creating a point
There's no y.
somewhere else, right? Technically, do you understand this is the point? This is a point, and this is a point, right? It's not together a point. Do you understand the difference? Okay. Ready? 2 brackets. Equals 0. If you forget to write me equals 0, you're losing points because that's the purpose of this. Okay, x times x, front, front. We got to get good at our multiplication table in this unit. What multiplies to 30? 5 times 6. Okay. Both negatives, because I do need them the same to make a multiply to a positive. So they both have to have the same sign.
That was weird. Yeah. Yeah. I don't even know what that's about.
Okay. I should... Oh, does that say negative x squared?
Oh, yeah. Where? Negative x squared.
Okay. This is what it says? Is this a simple trinomial? No. It's got a negative 1 in front of the x squared, so that's not a simple trinomial. So, how could I make it a simple trinomial? And you did this last unit when you did that completing the square thing.
How did I get simple trinomial? Oh, what's the math? You put a unit there. What?
This is how I do that. Remember, on that complete the square, you had to take that number out. Factor it out. GCF it out. Okay. What does this unit turn into now? X squared, positive x squared. That's what I like to see. This unit will turn into a plus 13x and a plus 22. Because I divided a negative 1 out of everything. Okay, don't forget on GCFs, you can always check, does this multiply to your original?
When you're making a complex trinomial, when you're taking a complex trinomial and you're turning it into a simple one, you always divide everything by the slope.
Yep, yep, yep. I divided it out. I mean, in this case, it's the same thing. Multiplying and dividing by negative 1 are the same math numbers. But, well, yeah, like something like that, right? It probably doesn't even factor, but like what would I do to change that? 2 out. So if I took the 2 out, what is the new simple trinomial?
X squared plus 3x plus 15.
Okay, does that make sense? Okay, so I took the negative 1 out. Okay, so now here's what I'm going to do. Negative 1 is just a constant multiplier, so it just stays. Then, now I just worry about that simple trinomial. I didn't lose the negative 1. It can't just disappear. Math can't just disappear. It's not going to affect my answer. Okay, multiplies to 22. 11 times 2 plus. So x equals negative 11, negative 2.
Okay, pause. What about this negative 1 here? Pause.
Okay, here's the deal.
Yeah, I need to know this deal.
Negative 11 and negative 2 are my x-intercepts. What did the negative do to this thing? What's the negative applying?
When you multiply, won't they be positive? Like, wouldn't the x-intercept be positive because the numbers would be negative?
I'm still worrying about what am I plugging into this.
Yeah, but that doesn't matter because there's still one just randomly there.
Yeah? Oh, what is it affecting?
Does it not change the x though?
No, it doesn't change the x. What does it change?
You No, I don't like this one.
The slope and the way of it.
It's just changing the direction of opening.
Okay, but we can't change a graph like that.
We just learned how to do that.
I got it if you want more.
So if I didn't have that negative in front, my situation would have been the same locations, but up.
All right.
All this did was flipped it, going through the same things. Okay, so it's there, but it's not anything to do with your variables. It doesn't have a variable on it, so it's not considered with our variables.
It's not even part of it.
It's not part of our solution.
Use that one now. We use it
Yeah.
to make it a positive.
Yeah, it's just
Wow.
there.
People.
Yep. Okay, let's do some GCFs. These will be fast too. We are on a recap here. Okay, so a GCF means what's common I can take out of every single term. I can take a 1x out. Okay, so visualize if you took this term and divided it by x, it'd be x.
Yes. And then
Subtract
subtract 12.
12.
Equals 0. Why did I do
Okay, here's what I suggest. Double check. How do I double check? Does this multiply
Yeah.
to your original?
Okay. And then x would equal like.
Okay, we have to consider every variable. So what would I like the x to be in that location to make that value 0?
0.
Good. That was a tricky one.
Not really. I just looked at the answer.
Oh. And here I would want x to be
12.
positive 12.
Okay. Yeah.
Because to make this multiplier, this is a multiplier, to make it 0, x would be 0. To make this multiplier 0, the x position would be 12. Okay. What am I taking out of every term? Every single term has to have it. 1x.
Then it would be x squared, right?
X squared,
And then 3 squared? Wait, no. 3x.
3x,
Oh.
subtract 18. Okay, again, GCFs, it's always good to just quickly double check, am I multiplying it back to that? Yeah, because these factoring and a distribution or foiling are completely opposite, so we can go back and forth as much as we want. Okay, you had this example in grade 10. I factored it with GCF, but now what can I still do? I can still now do a
The one you did.
simple trinomial. So this one, you should have seen this example in grade 10. It's where you've factored twice in one question. Okay, what should I do with the front x though?
Keep it there.
Keep it there. It can't just magically disappear, and I get
Just
that.
like -1.
I get that a lot. It can't disappear. Okay, so I'm going to do that part.
And then, oh, and then you can do like -6 positive.
So x times x multiplying to -18. 6 and 3. Because of that negative, one of them will be negative. Okay. This is not a quadratic, by the way. This is actually called a cubic function. You will learn in grade 12. Because, right, it's a cubic. It's more than squareds. We got cubes. There's 3 answers.
First x equals 0.
There's an x that would equal 0,
And then -6.
-6, +3. Do you want to know, just for the fun of it, what it might look like?
Not really.
Because I'm going to
Please. Ooh.
my grade 12s will get to do that. Right? It crosses at -6, at 0, and at 3. So it's going to make a different shape. But
So supposed to just be a straight line.
Well, it has to have a curve in it to make it go up and back down to that, and then, right?
Oh yeah, that's the cross every
Yeah.
point.
Okay. No, not right now. Like 3 flakes. Okay, what can I take out? 8. Okay, so that's what I want it to look like. What happens if I divide by 8? X squared. Subtract 4. Okay. The 8 is just 8 right now. There's nothing to do. All right. What, grade 10, can I do with that?
That is a difference of squares.
A difference in grade 10.
Kind of offensive.
Well, I haven't taught you this yet because you learned it in grade 10.
Oh,
Like, what did you learn in grade 10 about that? You learned that that is called a difference of squares. Okay. So a difference of squares, you make 2 brackets. The first times the first makes x squared. The last times the last makes -4. And did you know this? It technically has to add to 0 in the middle. Do you understand a difference of squares technically looks like this? So it has to add to 0 in the middle. Okay? Oh, that's where that comes from, okay? It's a simple trinomial without a middle, so it's 0 in the middle.
It doesn't matter which side the positive.
No, if you had, like same here, if somebody had on this, if they had x minus 3 and then an x plus 6, that doesn't matter. Your order will not matter. So, because it's multiplying, it's like me saying 4 times 5 is the same as 5 times 4. It doesn't matter, yep. Okay, so we have 2 answers, +2 and -2. Okay.
And then it wouldn't be an x equals 0 and not a third one.
Right. That's just an 8, so it's not even in consideration as an answer. Okay, last example of the day. So I've told you it's a difference of squares. So I'm going to start with 2 brackets. Okay, what times what will get me an a to the 4th?
A squared.
Okay. Do I know this one? Do you know this one? 256. 16 times 16. Plus minus. Okay, not done. I can do it again. Here's the reason why I picked this question. Do you understand that this will not break down again?
Yes. Yeah, because there's no minus. There has to be a minus. It can.
It cannot break down. Here's the reason why.
Because one of them is can't you do the negative one and then not the positive?
No,
You
can't you add it?
one.
Can't you add it at the end?
You like have you have 3 brackets? I thought that's how we did it.
Okay, when I look in this bracket, here's what's going on. To produce a 0, a squared would have to be what? -16. -16. Could I square anything to ever be -16?
No.
Not possible. Doesn't change. So leave it. A squared will not be allowed to be a -16. It's just not going to work. right? Because you can't square something to be negative 16. We talked about that on that last example. This is a difference of squares recognition
That
though.
one we can do.
That one will break down. Okay, so we talked about this piece would have no solution going forward. Just that piece.
A would equal 4, negative 4, and negative 16.
No, A is just negative 4, positive 4.
So the 16 means nothing.
This, if I worked through it, it's like this. A squared equals negative 16. I tried to square root that.
It would equal the error.
It'd be a no solution.
Wait, so you don't have to write anything?
So you don't.
You know what? We're just leaving behind numbers. Yeah, thank you. Please a little harder.
So that, just that part of it has no solution on that part of it, but then the final solution is those ones.